Hello viewers, welcome to the channel Amazing Civil Engineering Studies. Time to enter the world of civil engineering. Here we will learn about different concepts related to civil engineering. Please subscribe to the channel and press the bell icon for more new updates. In today's video we are going to discuss about soil engineering. Permeability of soil. Why is it important to determine soil permeability? Soil permeability is the property of the soil to transmit water and air and is one of the most important qualities to consider for fish culture. A pond built in impermeable soil will lose little water through seepage. The more permeable the soil, the greater the seepage. Some soil is so permeable and seepage so great that it is not possible to build a pond without special construction techniques. Soils are generally made up of layers and soil quality often varies greatly from one layer to another. Before pond construction, it is important to determine the relative position of the permeable and impermeable layers. The design of a pond should be planned to avoid having a permeable layer at the bottom to prevent excessive water loss into the subsoil by seepage. The property of the soil by which it permits the flow of fluid through it is called permeability of the soil. The porosity in the soil material is contributed by the presence of interstices within it. The property of permeability emerges when these interstices are connected, bringing a pathway for the movement of fluids. Generally, the soil is porous and permeable in nature. A soil with high porosity has high permeability. A soil with a smaller value of permeability is categorized as impervious. Importance of permeability. The following applications illustrate the importance of permeability in geotechnical design. Permeability influences the rate of settlement of a saturate soil under load. The design of earth dams is very much based upon the permeability of the soils used. The stability of slopes and retaining structures can be greatly affected by the permeability of the soils involved. Filters made of soils are designed based upon their permeability. Permeability is one of the most important engineering properties of the soil that is a solution for a number of engineering problems encountered in construction. Some of them are settlement of foundation and buildings, seepage below the earth structures, seepage through the earth structures, the yield of the wells, control of hydraulic stability of masses. For designing filter in hydraulic structures in order to prevent piping. Total head in hydraulic head. The flow of water through the soil is dependent on the permeability of the soil and the hydraulic head causing the flow. Figure below shows two vessels armed with water, that is connected by means of a small tube which contains soil sample. The length of the tube B L The total head at any point in a flowing fluid is the sum of elevation head, z, pressure head, and the velocity head. The flow of water in soils are extremely slow, hence the velocity head is neglected. The elevation head is the distance from the datum line to the point about which the hydraulic head is determined. The pressure head is determined by means of a piezometer whose tip is placed at the point at which the head is determined. From the figure above, the total heads at point 1, 2, and 3 are determined and tabulated below. From the total head determined, H is called as the hydraulic gradient. Point. Elevation head, Z. Pressure head. Piezometer reading. Total head. 1. Z. 1. H. 1. H2. Z. 2. H. 2. H. 3. Z. 3. H. 3. 0. Hydraulic head is defined as the difference in elevation of the water levels at the entry and exit points of the soil mass under consideration. The hydraulic gradient is defined as the loss of head per unit length of the flow of fluid through the soil. It is also called the effective head. The hydraulic gradient is represented by I, which is given by the formula I equals H/L, where H equals hydraulic head, L equals length of the soil specimen. Darcy's law and coefficient of permeability. Darcy's law studied the laminar flow of fluid in a homogeneous soil profile and demonstrated that the velocity of flow, v, is directly proportional to the hydraulic gradient I. That is V equals K times I, where K is a constant called coefficient of permeability. This velocity of flow is also called a superficial velocity or discharge velocity. If the discharge velocity, v, is known, the discharge, q, can be obtained as Q equals V times A equals K times I times A, where A is the cross-sectional area of soil including both the solids and voids. When the hydraulic gradient is equal to 1 K equals V. Hence, the coefficient of permeability can be defined as the velocity of flow occurring in the soil for a unit hydraulic gradient. The unit of coefficient of permeability is millimeter SEC or centimeter second or meter day. Coefficient of permeability for different soil types. The coefficient of permeability is dependent on the particle size, structure of soil mass, void ratio, properties of water, the shape of the particle, water impurities, adsorbed water, etc. Serial number Type of soil coefficient of permeability. MMSEC. Drainage properties 1. Clean gravel 101 to 102. Very good 2. Coarse and medium sand 10-2 to 101. Good 3. Fine sand, loose silt 10-4 to 10 to 2. Fair 4. Dense silt, clayey silts 10-5 to 10 to 4. Poor -8. -5. Factors affecting permeability of soil. A soil is said to be permeable when it allows water through it. There are various factors such as void ratio, size, and shape of the particle, degree of saturation of soil, etc., which are affecting permeability property of soils. Before going to know about these factors, take a look at the general expression for coefficient permeability, which is derived from the comparison of Poiseuille's law with Darcy's law, where K equals coefficient of permeability, C equals shape constant. Factors affecting permeability of soils. Following are factors affecting permeability of soils. Size of soil particle. Specific surface area of soil particle. Shape of soil particle. Void ratio. Soil structure. Degree of saturation. Water properties. Temperature. Adsorbed water. Organic matter. Size of soil particle. Permeability varies according to size of soil particle. If the soil is coarse-grained, permeability is more, and if it is fine-grained, permeability is low. The relation between coefficient of permeability, K, and particle size, d, can be shown from equation 1, as follows. KAD2. Specific surface area of particles. Specific surface area of soil particles also affects the permeability. Higher the specific surface area, lower will be the permeability. Ka1/specific surface area. Shape of soil particle. Rounded particles will have more permeability than angular-shaped. It is due to specific surface area of angular particles is more compared to rounded particles. Void ratio. In general, permeability increases with void ratio, but it is not applicable to all types of soils. For example, clay has high void ratio than any other types of soil, but permeability for clays is very low. This is due to the flow path through voids in case of clays is extremely small, such that water cannot permit through this path easily. The relation between coefficient of permeability and void ratio can be expressed from equation 1 as for clay kiss as shown in formula, where C equals shape of the flow path, E equals void ratio. For coarse-grained soil, C can be neglected. Hence, soil structure. Structure of any two similar soil masses at same void ratio need not be same. It varies according to the level of compaction applied. If a soil contains flocculated structure, the particles are in random orientation and permeability is more in this case. If the soil contains dispersed structure, the particles are in face-to-face orientation, hence, permeability is very low. The permeability of stratified soil deposits also varies according to the flow direction. If the flow is parallel, permeability is more. If it is perpendicular, permeability is less. Degree of saturation. Partially saturated soil contain air voids which are formed due to entrapped air or gas released from the percolating fluid or water. This air will block the flow path, thereby reduces the permeability. Fully saturated soil is more permeable than partially saturated soil. Water properties. Various properties of water or fluid such as unit weight and viscosity also affects the permeability. However, unit weight of water will not affect much since it does not change much with temperature. But when temperature is increased, viscosity decreases rapidly. From equation 1, permeability increase when viscosity decreases. Temperature. Temperature also affects the permeability in soils. From equation 1, permeability is inversely proportional to the viscosity of the fluid. It is known that viscosity varies inversely to the temperature. Hence, permeability is directly related to temperature. Greater the temperature, higher will be the permeability. That is the reason seepage is more in summer seasons than in winter. Adsorbed water. Adsorbed water is the water layer formed around the soil particle, especially in the case of fine-grained soils. This reduces the size of the void space by about 10%. Hence, permeability reduces. Organic matter. Presence of organic matter decreases the permeability. This is due to blockage of voids by the organic matter. A simple field test for estimating soil permeability. Dig a hole as deep as your waist. Early in the morning, fill it with water to the top. By the evening, some of the water will have sunk into the soil. Fill the hole with water to the top again, and cover it with boards or leafy branches. If most of the water is still in the hole the next morning, the soil permeability is suitable to build a fish pond here. Repeat this test in several other locations as many times as necessary, according to the soil quality. Determining coefficients of permeability to obtain a more accurate measurement of soil permeability, you can perform the following test in the field, which will give you a value for the coefficient of permeability. Using a bucket auger, drill a hole about 1 m deep in the soil at the location where you wish to determine the coefficient of permeability. Fill the hole with water to the top. Every 5 minutes, for at least 20 minutes, refill the hole to the top to be sure that the soil is fully saturated. Top the water in the hole and start measuring the rate at which the water surface goes down, using a watch to measure time and a centimeter graduated ruler to measure the distance p between the water surface and the top of the hole. Stop measuring when the rate becomes nearly constant. Measure exactly the total depth of the hole, h, and its diameter, d. Express all measurements in meters. M, for example, h equals 1.15 m and d equals 12 cm or 0.12 m. For each of the above two consecutive measurements of time distance, calculate the coefficient of permeability using the formula K equals QA. The discharge of water per unit area per unit hydraulic gradient is called coefficient of permeability. Definitions. The coefficient of permeability of a soil describes how easily a liquid will move through a soil. It is also commonly referred to as the hydraulic conductivity of a soil. This factor can be affected by the viscosity, or thickness, fluidity, of a liquid and its density. The number can also be affected by the void size, or region of non-soil, void continuity, and soil particle shape and surface roughness. It is an important factor when determining the rate at which a fluid will actually flow through a particular type of soil. The total head difference is defined as the distance from the point of the cone where water first enters the system and is at steady flow to the point at which the water is exiting the system through a flow tube and being collected in a graduated cylinder. A flow net is a graphical method by which one can characterize the flow of a liquid through a soil. When performing the calculations associated with a flow net, it is important to know the coefficient of permeability, or hydraulic gradient, of a soil. Thank you for watching. For now, please subscribe, like, share and do not forget to press bell icon.